Hello everyone, welcome to this video. In this video we have to find the sum of first n terms of the series. Now this series is given to us. Can you see the pattern here? Can you say this is an AP? The answer is no. Why? Because 7 minus 3 is 4, right? Then 13 minus 7 is 6. Then 21 minus 13 is what? It is 8. Then 31 minus 21 is 10 and so on. So you see we do not have a term, the common difference, as constant. So therefore this does not form an AP. What about GP? If you divide 7 upon 3, this is not equal to 13 upon 7. So this is also not a GP, right? Now it is not an AP, not a GP, right? So can you find out the nth term from it? It seems quite difficult to find the nth term. So what else we can do here? For if you see here, once you were calculating this common difference, the common difference show a pattern. This is D, right? When you subtract A2 from A1, this is A3 minus A2. What is this? This is A4 minus A3. This is A5 minus A4, right? And so on. So you see we have a pattern here for D, which is 4, 6, 8, 10 and so on. So this D forms a AP. So you see we have a AP inside, we have AP of the common differences which is hidden behind in between this. So how can we solve this? So basically in order to solve this, in order to find the sum, we have to reach at this inner layer D. We can reach at this inner layer by subtracting this from itself. How we can do that? Let us suppose that the sum of first n terms is Sn. So we can subtract this Sn from this Sn by shifting the terms, right? The last term is An. So we can write this Sn by shifting it to one place, so that we start from the first term would be written exactly below the second term of the above series, right? So now what we can do, we can subtract them. So Sn minus Sn would become 0 here. 3 minus, there is nothing, so we can assume 0 here. 3 minus 0 is 3. Then 7 minus 3 is 4. Then 13 minus 7 is 6. 21 minus 13 is 8. 31 minus 21 is 10 and so on. Each term would subtract, right? Now here notice that this is an minus 1 and the last term is minus an. This is as such. This here we have to write minus an, right? So this is what you got from here. Once you have this thing, you can shift this term to the left hand side, minus an. So it would, when you shift it to this side, it would become plus an, like this. All the other terms, 3 and whole of this term, could be written like this. This is up to how many terms? This is up to n minus 1 terms. So instead of writing this thing, we can write, we are doing is this up to n minus 1 terms. Okay. Now you see we can very easily solve this sum. This is an AP, right, with the first term as 4 and the common difference as 2. So we can apply the formula of sum. You know the sum of first n terms of an AP is n upon 2, 2a plus n minus 1 times of D. So here we are going up to n minus 1 term. So it would be n minus 1 upon 2. 2 into the first term, which is 4, plus n minus 1 into the common difference, which is 2, right? So now you can solve this and simplify. This is the same. This is 8. This is n minus 2 into 2, right? So next you can further simplify the terms. You can take 1 by 2 common from all the terms. So it would become 6. It would become n minus 1 into this expression. So n minus 1 into 8 plus 2 into n minus 1 into n minus 2. Correct? Next you can open up the brackets here, simplify the terms further. So you have this, you can add and subtract the like terms. So this is power 2 term, this both forms a power 1 term. So plus 8n minus 6n is plus 2n, plus 6 plus 4 is 10 and 10 minus 8 is plus 2, correct? So you have this term. Now this 2 gets cancelled with each of this term after taking common. So you are left with n square plus n plus 1. This is your an, nth term. Now once you know the nth term, we may not be able to get the nth term directly, but we obtained it through this method, right? By identifying that we have a GP of this common series. So we have just subtracted the two series from each other. Once you have your nth term, you can very easily compute the sum. The sum is calculated by adding all the terms together. So it would be a1 plus a2 plus a3 up to an. So instead of writing it, you can write it in terms of symbols where this k varies from 1 to n. This is a dummy variable. You can use anything in place of this k. It represents that we have to substitute in place of k different values starting from 1 to n, and we have to write plus in between, correct? This is just a notation. So now we can substitute the value of ak. If your an was this, so your ak would be k square plus k plus 1, right? Substituting in the value of n is equal to k into this expression. So this is this. Now you can separate out the summation on each term. So we would have this term. Right now, you know the sum of first n, the sum of square of first n natural numbers is n plus 1 to n plus 1 divided by 6. The sum of first n natural numbers, it is n plus 1 divided by 2. And when you add 1 to itself n times, it would be n, correct? Now, what you have to do, you just have to simplify the terms. You can take 1 by 6 outside, so that you have to take the LCM. So this term would come as such. You can multiply these two brackets together to get this term. Now here we would have to multiply by 3, so it would be 3 into n square plus 3n, right? And here we have to multiply by 6. Why? Because we are taking the LCM. Next, you can multiply these brackets together also. You can add up these two terms to obtain 9n. Now you can collect the like terms. 2n cube is as such. Then 3n square plus 3n square is 6n square. And then you have n plus 9n is 10n, correct? Now what you can do, you can take 2 common from this term, so it would be 2 into n cube plus 3n plus 5. So this 2 and 6 gets cancelled, so you have this term, which is your answer, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.